Okay, so kicking things off with number. Now when you are looking at a question with different combinations, have a look at how many selections there are and just multiply them together. So for a question like this, 5 times 5 times 5, or if you have to reduce them because there are different possible combinations where you can't include the first, you have to reduce before you. If you have slightly more complicated surds, you do need to think about your difference of two squares, so identify what's on the bottom and multiply by the same thing with a different sign. You may have to expand some double brackets here, so being very careful with your double bracket process and simplifying any surds along the way if you need to. When we simplify this, we get 4 root 2 plus 2, and on the bottom we get 2 minus 1 with that difference of two squares where you just have to multiply the firsts and the lasts. If you do have a 1 on the bottom, it can cancel out, but again, look to simplify. When you have a reverse percentage, you may have multiple steps. So we want to reverse this process, having a look at the different elements of the profit or loss in each year for this question. Here there was a loss in the final year, so that was 90%, and when we reverse that back to 100%, that can then move into that middle year. Here it was a profit of 20%, so again we can reverse that using our normal reverse percentage method and then get back to our starting number. When you're looking at bounds, if you have a fraction, it's a little bit more complex, but we need to write down the error intervals for each number in the question. Here we only have one, so we write the error interval for C, and then we can actually use that and substitute it into our formula. So for this one, the upper bound would use the larger bound there, and for the lower bound, we would obviously use our lower bound. Plug them both in, and if you're asked by considering bounds to work it out to a suitable degree, you want to see how they both round the same. So for this one, they don't round the same to 3 significant figures, but they do to 2 significant figures. So for this one, we would just write 2 significant figures, and that's how we go about our bounds questions. Okay, moving on to algebra. If you have to rearrange a formula, you may have one of the subjects in 2 different places. So get rid of any fractions or brackets. So here we're getting rid of the bracket by expanding and multiplying that denominator over. Once you've done this, whatever we want as the subject, we want them all on the same side. So I've moved all the f's to the left and the d's to the right, and then we can factorise that left-hand side so that those two f's look like or turn into 1. We can then divide and get that as the subject and put it on its own. Really common questions. If you have to factorise something like this and you can't spot how to factorise it, it might be that you can just take something out as a single bracket, and then you may spot that there's something like a difference of two squares. So for this one, 5 plus y and 5 minus y, but we'd only spot that once we factorise the 2 out. You may have something with letters that looks a little bit more complex. If you do, just obviously, hopefully you'll spot that that's a difference of two squares. Nice and simple for that one. But if you're asked to use that in a further question, just look at what's in the question, how that can be applied to what's above. So here A was an actual expression and so was B. We could just sub that in, simplify both brackets, and then actually look to multiply them. So quite a complex one, but just something like this, don't let it put you off. Just have a look at how you can apply that part B onto how the part A was given. If you have an nth term expression for a quadratic sequence, make sure you find the first and second difference. I know there's a formula that you can use for this, it's not the method that I use, but if you use this method, halve your second difference, it's going to tell you how many lots of n squared it is. You can then compare that to the previous sequence and then find the nth term of the difference. This one here is going down in 2's, and before the negative 2, if you added 2 the other way, it'd be 0. So it's just minus 2n. So it was n squared minus 2n, but you could have anything at the end there. When looking at a quadratic graph, we all should already know from the previous video how to plot a quadratic graph, so getting all those numbers in the table, plotting them very carefully onto your coordinate grid and joining them up with a nice smooth curve. Now you may be asked to find estimates. Now if it's not where it equals 0, where it's equal to something like this, where it's negative 2, you've got to draw a line through and find the x-coordinates where it crosses through the curve. If you have to draw an exponential graph, you need to know obviously what it looks like, but to find that coordinate where it passes through the y-axis, just put that power or that value of x as 0. If you have perpendicular lines, you need to know the negative reciprocal for your gradient. It may be that you have to rearrange the equation of the line before you can actually find that gradient. So here the gradient was 4/3 and the negative reciprocal is negative 3/4. You can then put that into y equals mx plus c and substitute any coordinate that you need into the equation of that line. That may be, a bit of a nasty one, it may be okay, but you're going to have to rearrange that to find the value of c. And if it's non-calculator, you may have some pretty nasty fraction calculations in there. So you just need to make sure you are confident with your fraction calculations and putting it all together at the end. If you have a tangent to a circle, particularly like this one where you have some nasty surds in there, it's always best to draw a diagram. So imagine where it looks like these are both positive, so it's in the positive quadrant. We can then sketch in a tangent and a radius. To find the equation of the tangent, you have to find the gradient of the radius, so rise over run, which is quite nice from 0, 0, and then you can again do your negative reciprocal of that once you've simplified it down, and again putting it into y equals mx plus c and substituting a coordinate in that is on the tangent. So for this one, not a very nice one where we had to substitute some surds in, but just following that process, multiplying everything down and simplifying any fractions where you can to find that value of c and ultimately writing your line equation. So not a very nice question there, but that's the process. If you have to form and solve equations, have a look at the question. It might be talking about area, it might be talking about perimeter. This one's about area, so write down any formulas that you need, substitute any algebraic values in, and then expand and simplify. And ultimately, if we are looking at a quadratic, we want it to equal 0 so that we can then factorise and solve. So for this question here, we can factorise that. We get two solutions. Only one of them works in this question. It's only the positive one. It's not always going to be the positive one, so substitute it into the size and just check to see which works. If you have to use the quadratic formula, it will give you a little hint there. Look on a calculator paper that it will be to a certain amount of significant figures or decimal places. So again, expand and simplify everything, make it equal 0, and then write your values of a, b, and c. So a in front of x squared, b in the middle, c at the end, and put it into the quadratic formula. Make sure you put it in very carefully, putting any negative numbers into brackets, particularly for the b squared, and then write your solution down in full and round it to however you've been asked. Swap the symbol to the negative and write down your full solution again, and again rounding it to however you've been asked. When looking at completing the square, you just need to remember to halve that coefficient of x. So for this one, 6 turns into 3. There's a negative symbol there. And then expand that double bracket and think what number would be at the end. This gives us a 9. We only want a plus 1, so we need to subtract 8, and there it is written in completed square form. To get the coordinates of the turning point from there, really nice and easy, flip the symbol in the bracket and the y coordinates at the end. If you have a slightly harder one, you are going to have to factorise out the coefficient of x squared first. So here we'd have to factor out 2, and then we would complete the square for what's inside. Here we're actually asked to sketch the curve. So we have quite a long process here because this just gives us the turning point. Once you've completed the square, you would then have to find the roots and the y-intercept. The y-intercept's at the end, so that's quite a nice one. The root, you could either use the quadratic formula or use completed square form, setting that completed square expression equal to 0, and then doing a nice little sketch where you plot all of the points on. If you have to do a quadratic inequality, we need to make sure that we're comfortable to factorise, so factorising your expression, then writing your two solutions, making sure you look at the factor pairs at the end, again flipping the symbols, and then it can really help here to draw a sketch of the curve, looking at where those roots are, and then look at whether it's above or below 0. This is above 0, so we've got the one on the right there where it's always going to be greater than a half, and we've got the one on the left where it's always going to be less than -2. So you've got to write those as inequalities. If you have a slightly harder question with quadratic inequalities, you may be asked a specific word where it says the area is greater than the other, or something along those lines. So again, write down your formulas, work them out as an algebraic expression for both, and then just put your inequality symbol in the correct way. So this one says the rectangle is greater than the area of the triangle, so we can set that equal to 0, factorise, solve, find our solutions like we have done previously, and then again you're going to be able to find your set of possible values. Again, being careful to substitute that value in and seeing which one works. If you have to look at quadratic simultaneous equations, there's a big process to follow, but follow all these steps. So rearrange the linear equation till it says x or y equals. We can then substitute that in, do your best to expand and simplify that. And again, we're ultimately trying to make this equal 0 so that we can go and factorise and solve it. So try and simplify it as much as you can till you get to the point of factorising. Of course, if you have a calculator, you can always use the quadratic formula. But once you've got your values, substitute them back into the linear equation to find your other values, whether that be x found first or y found first. When looking at iterations, make sure you read the iteration formula carefully. Remember, we're just going to substitute a number in and then repeat that process. So here we've got a formula and it says to start with 200. We need to then sub that in, find our value for the following term, whatever that might be. This is in months, and then just keep substituting that number in until you get to the final one that it's asking for. And as always, just read any Part B questions really carefully, making sure you answer them. When there's a number in the function bracket when we're looking at functions, you just need to substitute that into the function it's asked for. So -5 into the f function for the first one, and for this next one we have a composite function where we're going to have to sub 1 into g and then into f, almost reading from right to left. So sub it into g, get your answer, and sub that answer into f if it's written in this particular way. If we have a slightly harder question, we may be asked to do an inverse function. For this one, it wants us to work out the inverse, so swap f of x for y, make x the subject, and then if it's asking us to substitute a number into that, you can sub it in and simplify it, and this one actually asked us to show that it was 3. Here we have a composite function again, hg of x, so we're going to substitute the function g into h, just putting a bracket around both and swapping what's in the brackets, and then again for this one we are going to expand, simplify, make it equal 0 and solve it. If you have to factorise an algebraic fraction, have a look for these nicer, easier ones. You're just going to cancel off what's on the top and the bottom. Just remember, if it's only what's on the top that's simplifying, it's going to turn into 1. If you have a slightly harder one with more quadratics, again you want to factorise them and cancel off any common brackets and just write what's left. If you have a slightly harder calculation, like a division, don't forget your fraction rules. Always factorise everything that you can see, and don't forget when dividing, we do need to flip that second fraction. We had a slightly harder one on the top there, where you had to factorise x out first, and then it made a difference of 2 squares. And again, we were just cancelling out what's on the top and the bottom of both fractions. Don't forget you can also cross-cancel if there's something on the bottom of the left and top of the right, and simplify everything. If you are adding fractions, don't forget we need a common denominator. So here we need to multiply the left by x minus 4 and the right by x plus 2, top and bottom. Again, you can expand everything, add together those numerators. You don't need to expand the denominators for these unless you are specifically asked, but again, just simplifying everything down and writing it in its simplest form. When looking at graph transformations, just remember anything inside the bracket affects x, anything on the outside affects y. So that negative is inside the bracket, that affects the x, a negative symbol just changes the sign, and the -3 is on the outside, which just moves the y coordinate down by 3. Remember, if it's in the bracket, it will do the opposite of what you'd expect. When you are doing algebraic proof, make sure you know the terms for an even and an odd number. Again, there's a couple that you can use for an odd number. I tend to use 2n plus 1, but for here, if we are looking at squaring an odd number, we'd square 2n plus 1, which is a double bracket, and then here we're showing it's 1 more than a multiple of 4. You can see there's a plus 1 there, but if it is something else, you can break the number up, so plus 3 you could write as plus 2 and plus 1, and hopefully get your proof. On to Pythagoras and trigonometry. With Pythagoras and trigonometry, you do tend to have quite large questions such as this, so read the question very carefully and see what you can identify. This tells us the area of the triangle is 56, so looking at that triangle there, we'd have to find the missing side to apply it to half AB sine C. So plug in your values, rearrange it, and find any missing numbers that might have been on that triangle. From there, you can use that number to move your way onto a different triangle. So for this one, we're finding the broken line, or the middle line between the two. For this, we had to use the cosine rule, so make sure you know your formula very well. And then finishing this question off, we also had to use the sine rule. You need to be pretty well versed with all of these and making sure that you're happy and comfortable to apply them. When looking at 3D trigonometry, make sure you look at the question and label anything that's given to you very, very carefully. This one's asking us for the angle between the base and a particular line. From there, you can draw any triangles separately to the diagram and work them out using things like SOHCAHTOA or Pythagoras, but just make sure that you draw them out to the side so it's very clear and easy to see. Once you draw all over the diagram, it's going to be very hard to work out. When looking at a graph transformation, if you actually have to move the graph, and if it's a trig graph, just have a look at the equation carefully. This one here, the 2 is on the outside of the bracket, so it does affect the y coordinate, so a -2 moves it down by 2, making sure you move any whole number coordinates. Okay, on to statistics. When you're looking at capture-recapture, just read the question very carefully. We're going to write down as fractions each capture. So on the first one here, we had 90 bees were caught out of we don't know. For the next one, she catches 120 and 20 are marked. So there's our two fractions. All we're going to do is set them equal to each other and find how to make them equivalent. So for here, you've got to times the numerator by 4.5, so we just do the same to the denominator, and that will give us our total from the sample. Read any Part B questions carefully and just make sure you give an answer that makes sense. If you have to draw a box plot, just need to remember exactly what a box plot looks like. So it's going to look something like this. So go through any numbers or a table and figure out where those numbers are. So for this one, we are given a few of the values like the least, median, lower quartile, interquartile range, and the range. So if we put them in, the range will help us get from the least to the highest. We've also got the quartiles and the quartile range, so we can move between those and draw our box plot. If you have to compare them, there's two things we want to compare. So we want to get the value of the median and we want to get the value of the interquartile range, which tells us about the spread. So find the values of the median and make a comment about which one's greater. Just don't forget to mention the context. As well, the same with the interquartile range, and mention which one's more spread out. If you have to draw a cumulative frequency graph, you just need to remember where you're plotting the points from. So the points are on the end points, and just check that it is the cumulative frequency, otherwise you're going to have to add them up as you go down. Make sure you start on the right starting number from the table as well. So draw all the points on the end points, draw them up with a nice smooth curve, and then have a look to see if there's a part B. This one asks us to look at the interquartile range. So the median would be at 20 and the quarters would be at 10 and 30. So go across, read those values, and the range between them would be 27. Onto ratio and proportion. Okay, so for compound interest you may have to work backwards. It may want you to work out the actual interest rate. So set up your formula like you would normally. For this one, 5 years would be x to the power of 5. You can then rearrange that and do a fourth, fifth or third root, however many years it is that you need to. Just remember that your multiplier is 1.0 something, and that's something's the percentage. When looking at depreciation, you may be given it in a form of an iteration style question. So this one, it's losing 2% water per year, that would be 98%, and the decimal for that is 0.98. So if you had to do depreciation, that's what you'd multiply by. When looking at fractions and ratios, you may be asked to find something like this. So read each line, and you can always use a probability tree. So here, white shapes and black shapes was in the ratio 3 to 7, white circles to white squares was 4 to 5, and as well the final one, black circles to black squares, was 2 to 5. So you can write them as fractions as a probability tree, because here it asks what fraction of the shapes are circles. Identify the roots that actually apply to that, and multiply across like you would on a normal probability tree. You may have fractions at the end that don't add together very nicely, so you can always simplify them to help find a common denominator. Here we got a common denominator of 15, and that's simplified down to a third. For direct proportion, you need to know your formula well. So for direct proportion, you would write y is equal to k, and then whatever's there. Here we've got the cube root of x. Put in the numbers that you've been given. Obviously any mixed numbers, write them as improper fractions, and then rearrange that to find the value of k. Once you've got your value of k, you can put that back into your original formula and then use the second value if you are asked to use one. So here we need to substitute 64 in and just solve that to give us 2 and a third. You may also have inverse proportion. This one here has algebra in, but again we're going to set it up as normal, but y equals k over, for this one, x cubed. Then you'd want to sub in your values. Here we're subbing in some algebra and rearranging it to find the value of k. Once you've got that, put it back into your formula as we did with direct proportion, and then use those second values however you need to, and simplifying it down. This one wanted us to show it was 5.5. If you have a velocity time graph or a speed time graph, you may be asked to look at the area underneath it, or you may be asked to look at the gradient. This asks us to look at the area by breaking it into 4 equal strips. You need to know the formulas for the area of a triangle and a trapezium, and then you can go about working out the area of each shape and adding them together for the total distance. Just remember to look at your shapes. This one, they are under the curve, so this would be an underestimate, but they could also be over the curve. You may be asked to look at the gradient at a particular point on a curve as well. This is always quite fiddly to do. You need to find the point, you need to put your ruler on and try and draw as best your neatest tangent using a ruler and a pencil. From there you can find the gradient of that using rise over run by drawing in a right angled triangle, and try and find a run which is quite a nice number. 1 or 10 was normally quite a nice one, and this represents the rate of change, and in this case that's the acceleration. If you have ratios written like this, and you have algebra involved, you can actually write these as fractions. So you can write the left over the right is equal to, again, the left over the right. From there we have an algebraic fraction calculation, or an equation here, where we have to cross multiply, and again, like we have before, make that equal 0, factorise, and solve it. Okay, on to some geometry. If you have cones and spheres, again you'll be given the formulas for a sphere, so you just need to substitute the values of the radius into both of those formulas and then find them. If you are asked to write it in terms of pi, that's fine as well. You just need to make sure you're happy with squaring and multiplying. So for this one, we just had to find both volumes. You may also have the curved surface area, but you may have similar cones on this sort of shape where you have kind of like a frustum on the bottom. So for this one, we just find the ratio between the two. It was 3/5 of the length, the small cone, so it was 3/5 of the diameter, which allowed us to find the radius, and then again subbing that into our formula for the large and the small cone and finding the difference between them. If you have to do some transformations, you'll have a negative scale factor potentially. If you have this, find the centre of enlargement and then find the column vector that allows you to get to the first vertice on the shape. Multiply that by the scale factor and it will tell you which distance to go in, and you can get some pretty nasty ones when you have a negative scale factor. You may also have questions where you have to do multiple transformations, so make sure you're happy with your reflections, rotations and translations so that you can go about doing these multiple questions. Now, if it does mention something called an invariant point, that's a point that hasn't moved. That could be on the shape or it could be part of a transformation. This one was asking for an invariant point within a transformation and it was actually a rotation point, but it can be either. Just make sure you're very careful and you read that word and you know it just means a point that hasn't moved. If you have bearings, this may also be involved with trigonometry. Remember that bearings are measured from north, clockwise, and have 3 digits. So make sure you find which bearing it's asking for and then have a look and think about any parallel lines. Remember that co-interior angles make that C shape, so we can actually say that they add up to 180. You've got angles round a point that add up to 360, and if you need to apply the sine or cosine rule to a question, just hope that you are confident with actually applying those and make sure you're really happy with using those lengths within a triangle. So for this one we actually found the missing angle within the triangle. It was a combination of two, so we had to add them together and give it as our 3-digit bearing. You may have similar shapes and these can also involve ratios. Just remember to look at the scale factors. This particular one gave us a surface area ratio and it gave us a volume ratio, but to compare them they had to both be in height, so we had to square root the surface area numbers and cube root the volume numbers. We could then form a 3-part ratio to find the relationship between A and C. So make sure you're happy with your 3-part ratios, just making that same number in the middle. Once you've got the number in the middle we could identify the ones we needed and simplify it as asked. For a circle theorem, you need to know lots of circle theorems, but double check, make sure you spot things like tangent to a radius and put a right angle in if you need to. From there you can apply your circle theorems along with things like angles in a triangle, which we had on this question, angles on a straight line, and then not forgetting things like isosceles triangles, which are very common in these exam questions. So base angles in an isosceles are equal, and then we could actually figure this out by just using tangent to a radius equaling 90. So some of the circle theorems questions don't even have too many circle theorems in. For this one you have a cyclic quadrilateral, and we also have a triangle that meets a tangent, so we also have the alternate segment theorem. So it's asking for this angle here. We know that opposite angles in a cyclic quadrilateral add to 180. We could find that one there. Angles in a triangle add up to 180 as well, and then we could actually apply that using the alternate segment theorem, which was a nice relatively quick question, but obviously there's lots that you could be asked. You may be asked to apply circle theorems in parts of geometric proof as well. This one was asking you to prove two triangles were congruent, which means that they're exactly the same. So identify the ones it's asking for and then think about how we can find that any sides or lengths are the same. For this one, we could find some angles as it told us it was an equilateral triangle, but from there we had to apply some circle theorems. So we could do the same segment angles are equal, and that was one of the ones that allowed us to find some further angles. But go around the shape, finding anything that you can, and if you can identify a couple of angles, you're probably onto a winner. You just need to then find a side as well, or potentially a couple of sides and an angle as well. This one we had the same side on both, and it meant that they were AAS triangles, so don't forget your conclusion. With other geometric proofs, you may actually be given most of the answer in the question. So this one here, we had to show that these two triangles were congruent, which would then show that AC was equal to BC. So we could find that 2 of the lengths were the same as given in the question, 2 of the angles were the same which was given in the question, and then they both shared a similar line, so therefore they were SAS triangles, and therefore the lines must have been the same length. With vectors, obviously there's tons of questions that you could have. You could spend 30 minutes on this topic at least. So make sure you label any vectors that move around the shape. From there, try and find the vector which applies to any line which is not given. This one here, FE, was not given, so we just had to move around finding that. If you are asked to find particular ratios of lines, you just need to have a look and find the vector for any line that is not given again. Here we're not given the one that is highlighted in green, so you just need to think how you could get there. You might have to do half of a vector or a quarter of a vector to move along a particular point on the line, but just take your time working along and seeing if you can find any vectors, which might pick you up some marks. I remember with questions like this, it's very good to just try and get a couple of marks, even if you don't finish the question, because they are quite extensive questions and they're not designed for everybody to get full marks, and sometimes you don't even need to answer them to get a grade 9. But a good one to practice if you are aiming for that grade 9. Let's move on to probability. So with probability, you might have to do a quite large Venn diagram. So with one of these, you have lots of words. This particular one was a three-way Venn diagram. So you have to go through each statement, figuring out which numbers can be put in and being very careful to look for the language. So this one here, we had a particular line that said 4 speak French and Spanish but not German, which allowed us to put it in straight away. But then it said 7 speak German and Spanish, but it didn't say but not French. So we had to also incorporate the fact that there was already a number right in the middle of the Venn diagram. So you need to go through very carefully, figuring out any missing numbers, and then if you're asked any probability, don't forget your probability rules. Just because you aren't given a table doesn't mean that you can't put probabilities into a table. So this one says there was red, blue and purple, and it told us the probability of purple and red and blue in a particular ratio. So don't stop yourself from drawing a table if anything's missing, and this is a good tip for most of the topics, that if you need to draw a table or a diagram, then go ahead and draw it. But this one was then just sharing in a ratio. If you have to do a probability tree, remember those branches have to add up to 1, and when you're going along the branches, you just have to multiply. So add up all the branches, make sure they all add up to 1, put any information that's in the question, and then have a look at which branches you're being asked to go down. This one says work out the probability of winning exactly one of the two matches, so we could have a win and a loss, or a loss and a win. So multiply those both together, get your answers, add them up, and that's your total probability for that particular journey. If you have other questions as well, you may be asked to write expressions for probability, but not necessarily using a probability tree. Here says red to green, it said that green was 3/7, so therefore red was 4/7. Again, we could write that as an expression, but we didn't actually have to use a probability tree here. It just told us the probability after that the green was 6/13. So you could write the algebraic expression for green, set it equal to the numerical fraction that we had, and then cross multiply and solve it. But this one was nowhere near as tricky as that previous question, actually using a probability tree.